Diagonals of a parallelogram bisect each other. Let's prove it. Now this is a parallelogram. Let's call it A, B, C, D. Now the diagonals of this parallelogram are AC and BD. Let's say they meet at point O. Now what exactly do we want to prove? We want to prove that AC has a certain length, DB has a certain length. Say AC is equal to 14 centimeter and DB is equal to 8 centimeter. Now, when these two diagonals cross each other, then they are divided equally, which means AO will be half of AC and OB equal to OD will be half of DB. And here as well, AO will be half of AC and OC will also be half of OC will also be half of AC, which means AO is equal to OC and OB is equal to OD. This is what we have to prove, that when two diagonals cut each other, the diagonals are equally divided. That is, this side is equal to this side, this part is equal to this part, and this part is equal to this part. We will use the congruence rule of triangles to prove the fact. Let's begin. Now let's consider triangle AOD and triangle BOC. That is this triangle and this triangle. Let's consider it and we will prove that this side is equal to this side. Remember, this has not yet been proven that OB is equal to OD. We are yet to prove it. So, we have considered this triangle and this triangle. And using the congruence property of triangles, we will prove that these two triangles are congruent. And when it will be proven that these two triangles are congruent with parts of congruent triangles are equal, we will be able to prove that this side is equal to this side and this side is equal to this side. So let's begin. Now, at this point, I would recommend that you pause the video and try to guess which congruence property should be applicable here, so that we can prove that this triangle is congruent to this triangle. That is, triangle AOD and triangle BOC are congruent. Which property should be applicable? Should it be SAS, ASA or SSS? RHS is not going to hold here. Okay, let's begin. We know these two sides are equal because ABCD is a parallelogram and they are the opposite sides. So, AD is equal to BC. And now let's consider this angle. Let's call it angle 1, or forget about 1, 2 rules. Let's call it angle ADB. This is angle ADB. ADB. This is angle ADB, and if we extend it a bit, these are two parallel lines, and if we extend this diagonal, we will observe that this is acting, this DB is a transversal Angle ADB is equal to angle DBC. DBC, this angle. Why? Because they are alternate angles. And we know when two lines are parallel, when two parallel lines are cut by a transversal, the alternate angles are always equal. Now, we have one more pair of alternate angle. Can you guess which one is it? This and this. Angle BCA and angle CAD. Same rule, alternate angles. So we see that this side is equal to this side, this angle is equal to this angle, and this angle is equal to this angle. Therefore, we can conveniently say that triangle AOD is congruent to triangle BOC. And what should be the congruence rule? Definitely it is ASA, angle side angle congruence rule. ASA congruence criteria. So now that we know this triangle is congruent to this triangle, so we can conveniently say that OB is equal to OD and AO is equal to OC. Why? They are corresponding parts of congruent triangles, but they are the diagonals of parallelogram ABCD. And these two diagonals, when cut each other, they are divided equally. That is, the diagonals of a parallelogram bisect each other. When they intersect, they bisect each other. So that was easy.